The next topic that we'll be learning right now is regarding this pointer. And now this pointer is an important concept. It could be asked as a short answer question, or it could be asked as an application also. So we'll focus on what is the topic right now. We have to look into this program. So basically you can see that there's a class called test. Inside that you have a variable x declared, that is of data type int, and you have the function which is declared under public access specifier called setX, which has got an argument x over here. So kindly note there are two x over here. This one, basically it is the variable as part of the program, and here x under this function. Now you can see that this is basically an argument, or it can be treated as a local variable. Now this x, so there are two x variables over here, one which is a part of the program or which can be called by an object, and another one is x, which is a local variable which has got the same name as a member. So under this function setX, what basically happens is you have a statement called x equal to x, and then you have a function print whereby you are printing the value of x in quotes equal to, and then you'll be displaying the value of x. Now coming to the main function, you have an object called obj which is belonging to this class called test. Now you have a variable declared over here x, which is equal to 20, and then you have an object, this object obj, calling this function setX and calling the function print. Now what happens in this function when you try to execute this function? So obviously x is set to 20 over here, and which means this x will be storing the value 20, and that 20 is passed over here as a part of this argument. So this x, which is a local variable, which will be storing the value 20. Now this x is replaced with the value of 20. Now if we look into the previous programs, we had written about int quantity, int rate, and the total price arrow, which was respectively moved into the variables in the previous program. Just like that, you have a transfer of the value x that is passed as an argument to this variable x. Now typically what you expect as the output. So obviously you pass the value 20 over here, this 20 comes here, this x will be storing the 20 over here. Since this object is calling this x, it means it will be the variable x of the object, and when you try to print it, the object's x will be accessed and it should print the value. So typically the output expected will be 20. But on contrary, when you run the output, it will be 0, which means the value 20 that has been passed in the main program has not reached the corresponding x of that object. The reason is you have a certain confusion over here. Now, for the program perspective, it is not clear what is this destination x. Does it belong to the object x? Does it belong to the local variable x? It is not clear. So to solve this problem, we are giving a text over here, this and the arrow operator. Now we try running this program. And now the value has become 20, which means with the help of this pointer, we are able to retrieve the object's x, which is hidden by the local variable x. I hope this point is clear with regard to this pointer. So you can read along these notes for a better understanding, and as per the definition, my current concern would be this line, and basically it states this pointer is a constant pointer that holds the memory address of the current object. I hope that point is clear by the previous example also. Now, this pointer will also be helpful in a situation where you have multiple way objects trying to access the same variable. So again, with respect to the same program, we are having the variable x over here. Your argument is also declared as x. And now you have this statement over here, x equal to x. And you have and the variable which is, so here if you look over here, this program has a certain amount of difference. Instead of initializing a variable x directly, I have created an array of objects over here. So we can see that I have created an array of object called obj of size 4 over here, which belongs to this class test. And in this for loop, I am declaring my value for I equal to 1 and I less than 5, indicating it can go up to 1, 2, 3, 4. And basically I am initializing my x variable here with the value I. So x will be I. Initially it should be 1. And then object of I am having an array of objects over here. So each object will be executing this function set x as well as print. So I'm trying to run this program, and we can see that the output is not as expected. The first value turns out to be a random one and the remaining values become 0. Again, in this particular set of a problem, there are multiple objects over here compared to the previous one where we had a single objects. Here we have multiple objects. So we already know that when in the case of multiple objects, the memory shared by each variable would be different and the memory shared by the functions would be same between the objects. I hope you remember the topic called memory allocation for objects when we had done the first module. Over there we had learned that each object will have its own copy of the variable. Now just imagine the situation over here. There is an array of objects over here which will have its own individual x, but it is not clear whether this x belongs to that particular object or not. Again, this problem can be solved using this keyword and the arrow operator, which basically highlights the fact that that particular x at the left side belongs to this particular object which is calling. So we solve this particular problem with this pointer, and you can see that basically the value would have been I. So I is initialized with the value 1, so x is replaced with 1 and you have the corresponding display. X is 1, 2, 3 and 4. So I hope this concept is clear regarding this pointer. I have shown you 3 different examples of how this pointer helps. One is with a normal program and what the issue was, how it was corrected with this pointer, and how this pointer helps in accessing the correct variables when the number of objects are more than one, or when we are talking about array of objects. Hope this particular topic of this pointer is clear. So far we have begun with the fourth module, and basically we have covered the basics of pointers. Then we learned about the concept of pointers to objects, and now we have learned about this pointer also.